welcome back to Hall, also known as Teach as We Learn. Today I'm going to be teaching you about adding and subtracting exponents. So this is an exponent for those of you who don't know. This is an exponent. This is our base, not typed, and this is our coefficient. Okay. Basically, what all these words really mean is that our base is what we're multiplying every time, right? Then our exponent determines how many times we're multiplying it. So it would be like x times x. Our coefficient is basically a number in front of x. But that is pretty much it for coefficient, base, and exponent. So if you're given a problem like this, 3x squared plus 2x squared, first thing that you have to make sure is that our exponents are the same. Because it's a huge thing with exponents that you can never ever add different exponent values. They have to be the same. So it has to be a 2 and the second number has to be a 2. And then, then I just add my regular bases and I get 5x squared. However, this is a real big no-no. Suppose this was 3x squared, 2, and then this was 2x squared, 5, then I could not just be like, oh, this is 5x squared 7. No, I can simply not do that. This is nonsense. It's not true. But this is true. So basically, in adding exponents, you actually don't add the exponents. You simply just add the base and then keep your exponents the same. So let's maybe do some sample problems. I'll give you some time to do so. And yeah, so just pause the video whenever you want to pause it, suppose. Okay. So 6x to the power 4 plus 4x to the power 4 would be 10x to the power 4. 10x squared plus 10x 3, I can't solve it. So the reason for that I can't solve it is because, right, we never add those different exponents. But this is the most simplified way that I can keep it with. So this would just stay like this. Then I kept this problem for a reason. 9x plus 8x. All it really is what you could put an imaginary 1 there, but would just add up to be 17x. Or it could also be, 17x 1, which is really the same, which is literally the same thing. So I hope you were able to understand these problems. If not, that's all right. Just, rewind the video, try to see where you went wrong, and it hopefully makes sense. Then we come to subtracting exponents. Subtracting exponents, literally the same thing. So it might be 4x x squared minus 2x squared, I would literally have to subtract with those same bases, but instead of adding, you subtract. So it would be 4x squared minus x squared would equal to 2x and then power to the 2. That would be my answer. Another problem. 7x3 minus 5x3. Okay, 7 minus 5 is 2. Then you got to put those same bases and then those same exponents. So it's 2x to the power of 3. Literally the same concept as adding exponents, but we just subtract them. So again, I will give you a list of problems to do and, do them. Okay. So pause the video and solve it if you want to solve it. So first thing I check, same bases, yes. Same exponents, yes. And you also have to make sure they're the same bases as well. So it's 7x4 minus 4x4, 3x4. 7x minus 5x, remember those imaginary ones, 2x or 2x1. 8x3 minus 8x, most simplified way. We cannot subtract them, right? Because there's no 3 here. It's an 1 here, which makes us different exponent values. What if I gave you this problem? 8b2 minus 8c2. So I know, yes, they have the same exponent values, but the bases are different, so I cannot subtract that. So this is also the most simplified way I could do this. Algebra teachers love to trick you with that. So no, just be sure of that. So make sure your bases and those exponents are the same before you add and subtract it. So that's all it for today. I hope you enjoyed and see you on the